I'm Lavanya, Associate Professor, Department of Software Application. Today, I'm going to teach you about the scheduling algorithms in operating system. The topics to be covered in this video is, first thing, what is scheduling algorithms and what are the different types of scheduling algorithms available in OS. And in that, two important scheduling algorithms are going to discuss today. That one is priority scheduling algorithm and another one is round robin scheduling algorithms. So students remember, so these are the important topics. A regular short question will come in this topic. So be attentive. Let's see what is scheduling algorithm. Scheduling algorithms tells the CPU which will be the next process to have the CPU time. The main goal of scheduling algorithm in OS is to maximize the throughput, minimizing the waiting time, and reducing the response and ensuring the fairness. It helps to manage system resources efficiently and to optimize CPU utilization. So we have different types of scheduling algorithm in OS. Each scheduling have different characteristics and they are suitable for different scenarios. So there are so many scheduling algorithms available in OS. So in your syllabus, we have 6 to 7 algorithms. Let me tell you all the 15 scheduling algorithms. The first one is first come, first serve. And second one is shortest job first. Third one is round robin. And fourth one is priority scheduling. Fifth one is shortest remaining time. Sixth one is multi-level queuing scheduling. And seventh is multi-level feedback queuing scheduling algorithm. And eighth is lottery scheduling. Ninth is pair and share scheduling. 10th one is deadline scheduling. 11th is earliest deadline first. 12th, rate monitoring scheduling first. 13th one is weighted fair queuing. 14th one is guaranteed scheduling. 15th one is multi-queue scheduling. So first see the priority scheduling algorithm. So it is one of the method of scheduling process that is purely based on the priority. Scheduling selects the task to perform as per the priority. So this type of scheduling can perform system performance by executing important process first, and it can also cause starvation of lower process priority process. So in this priority, the process which has higher priority will execute first and followed by the lower ones. So process with an equal priority are executed on the first come, first serve basis on the or round robin basis. There are two types of priority scheduling algorithms. One is preemptive and another one is non-preemptive. So in preemptive scheduling, if a new process arrives with a higher priority than the currently running process, the current process is preempted and the new process gets the CPU. In non-preemptive scheduling, if once a process gets the CPU, it holds it until it finishes the request. If the CPU is taken away from a process by the arrival of higher priority process. So let's see an example for the priority. So consider we have a process ID of 5 process with the burst time and the priority. So process 1 has the priority of 3 and we have process 2 with the hierarchy of priority of 1. So we'll execute the process 2 first. So process 2 executes first with the 1 burst time. And the next priority will be given to the process 5. So process 5 will have the burst time of 5. So process 5 is executed in the second priority. So the burst time will be calculated as 6. So next priority was given to process P1. So P1's burst time is 10. So P1 is executed with the burst time of overall 16. So let's calculate the next priority, which has P3. So P3 has the burst time of 2. So which will be executed with the burst time of 18. And at last we have P4 with the burst time of 1. So overall the Gantt chart was calculated with the 19. So we'll calculate the waiting time for each process. The waiting time for P1 is 6 milliseconds. And the waiting time for P2 is 0 milliseconds because we started the P2 first. So it was started by 0. And the waiting time for P3 is 16 milliseconds. And waiting time for P4 is 18 milliseconds. And waiting time for P5 is 1 milliseconds. So we'll calculate the average waiting time. So all the 5 process waiting time is added, summed and divided by 5. So overall waiting time for this priority scheduling is 8.2 milliseconds. So let's check out the advantages and disadvantages of this priority scheduling. So advantages, priority scheduling allow for the allocation of CPU process based on the relative importance of the process. The time-sensitive task can be assigned higher priorities, ensuring they have the necessary computing time. So priority scheduling alone might not be sufficient for all scenarios. It can result in low priority process waiting indefinitely if high priority process continuously arrive. So to continue to resolve this problem, hybrid scheduling algorithms can be used to address such limitations by combining priority-based scheduling with other scheduling techniques. So next algorithm is round-robin algorithm. So before we have seen the priority scheduling algorithm, the second most important algorithm is round-robin scheduling algorithm. So before checking out the example, we'll see what is round-robin algorithm. So round-robin algorithm is the most important CPU scheduling algorithms. So it is a type of preemptive scheduling. So before the priority scheduling consists of two types. One is non-preemptive and another one is preemptive. But round-robin is only preemptive scheduling algorithms. It assigns a fixed time quantum to each process in a circular queue and treats all processes equally by sharing the CPU time. The CPU executes each process for one quantum and then switches to the next process in the queue. If a process does not finish within its quantum, it is moved to the back of the queue. If round robin provides fairness by giving equal CPU time on all the process and prevents starvation. In priority scheduling will leads to starvation. Here we don't go for starvation because each process will given the equal quantum time. So the quantum time is also known as time slice. So it also provides reasonable response time for interactive tasks, which each process receives regular time slots to execute their process. Let's consider an example for round-robin scheduling algorithm. We have three processes, P1, P2, and P3, and the burst time was given for P1 is 24, P2 is 3, and P3 is also 3. The time slice for this process is 4. So let's start executing with the first come first serve basis. P1 will execute only 4 because we have given time slice time quantum for only 4. So the 4 equal slots will be allotted for each process. Since we have 24 burst time for process P1, we will execute only 4 and remaining 20 will be executed later. So second process we have 3, so it is less than 4. So it's complete its process and then it's move on to P3 and P3 is also have the burst time of 3. It is lower than our time slice. So we executed P3 and we start executing only P1 which have 20 burst time remaining. So we used to divide all those 20 by 444 by executing P1 with the ending time of 30. So before that, we have to calculate turnaround time. So turnaround time will be calculated by the completion time minus arrival time. So the waiting time will be calculated by turnaround time minus burst time. So the waiting time will be calculated for P1 is 6 milliseconds and P2 is 4 milliseconds and P3 is 7 milliseconds. So I think you have understood what is priority and what is round robin. So priority in the basis, process will execute according to the priority which was given. So in the round robin, it will use time quantum for each process. So shall I check your knowledge regarding which I have taught you? First question for you. Consider a priority-based scheduling algorithm used in an operating system The algorithm assigns priority to process and schedules them based on their priority level. Which of the following statement is true regarding this algorithm? Can you have a guess? Yes, the option is A. Question number 2. If a round robin algorithm, scheduling algorithm with time quantum of 10 milliseconds, if there are 5 processes ready to execute with burst time of 25 milliseconds, 15 milliseconds, and 30 milliseconds, 10 milliseconds, and 20 milliseconds. In that order, which process will complete execution first? Can you have a guess? Remember that quantum of 10 milliseconds is given. So which will execute first? Yes, you are right. Option is C. Process 3 will execute first. In a priority-based scheduling algorithm, if two processes have the same priority, how they are typically scheduled? Yes, round robin. In a round robin scheduling algorithm, what happens if a process burst time is greater than the time quantum? Yes, option is A. The process is preempted and moved to the end of the queue. What a scheduling algorithm can, which scheduling algorithm can be considered an extension of the priority algorithm where processes are divided into multiple priority levels? Can you guess the answer? Yes, it's option C, multi-level queuing scheduling algorithm. So we have in this portion, I think you all come to a conclusion regarding scheduling algorithms. So let me sum up what are the things we have learned today. So we have learned scheduling algorithms. What are the different types of scheduling algorithms in operating system? And we have seen two scheduling algorithms. One is priority-based scheduling algorithm, and another one is round-robin scheduling algorithms. So these scheduling algorithms is very, very important for your exam point of view. So please make use of it. Thank you so much for listening to me patiently. All the best. Thank you.